So now that you've learned how to find side lengths and angles in right triangles using trigonometry and the Pythagorean theorem and things like that, we're going to see how you can put all of that together to do something called solving triangles. But what does that mean exactly? It's a pretty generic sort of term for a method, so what it comes down to is if we want to solve a triangle, really what we're trying to do is just find everything in that triangle that we don't know. So we want to find all the unknowns in the triangle. And that includes both angles and side lengths. So that means you're going to take what you're given, and it'll be a little bit different depending on the situation, and you're just going to find every single possible piece of information about that triangle that you can. There's not really much else to it, so let's just give it a shot. So you can see here we've got a pretty standard looking right triangle. We've got one side length and one angle. And so our goal, if we're solving this triangle, is going to be to find all the other things in this triangle that we don't know, which would be this side over here, this side over here, and then this angle as well. So we have three things that we don't know that we're going to need to figure out using the three things that we do know currently. So just like most other trig problems, what we're going to do is we're going to start by deciding which side is our opposite and our adjacent and our hypotenuse. And you should be pretty familiar with that at this point. So our opposite is over here, our adjacent is 18, and our hypotenuse is up there. Now we're just going to pick one particular thing to start with. We've got three different things we need to find out. So we've got our opposite, our hypotenuse, and angle B up here. And we can do any of those in any particular order we want. So for me, I am going to start with my opposite. So if we're focusing on the opposite side over here, we need to decide how we're going to get that. So could I use Pythagorean theorem? Could I use trigonometry? Depends on the situation. For us, this is going to be a trigonometry question. And based on the fact that we want the opposite and we know the adjacent, we're going to be using one of our ratios. So if we look at our SOHCAHTOA again and say, all right, I have the opposite, I want the adjacent, that is going to be tangent. So let's get that down. So remember, our tangent ratio is the opposite over the adjacent. This is just like any other trig question you did last week. So we're going to plug in everything we know. Our angle is 25 degrees. Our opposite we don't know, so I'm just going to leave it as opposite for now. Or we can also call it side A, because remember, angle A and side A are related. But I'll just leave it as the opposite. Our adjacent is 18. And now we just solve this the same way we've solved all the other ones. So I want to get that 18 out of the bottom of my fraction. I'm going to multiply both sides by 18. And so we get our opposite side is 18 times the tangent ratio, 25 degrees. This is where you get out your calculator and make sure that it's in degrees, not radians. Plug that all in and calculate. I'll give you a few seconds to try that out for yourselves. And so once you've done that, you should hopefully get 8.39 meters. So that's one thing we figured out. We've got 1 out of 3. So we now know this side over here is 8.39 meters, which is good. So now we move on to our hypotenuse. And we're going to go through basically the same process. We want to figure out what that unknown side is, and so we decide which ratio to use. And so you might think there's multiple options here, and there are. We could use our 18 meters again, or we could also use that 8.39. But I am going to tell you that you should generally not use things that you've calculated to calculate further things, unless you have to. Because the issue is, if we made a mistake down here calculating this 8.39, and then we try to use that to calculate something else, no matter how good our steps are, our answer is going to be wrong because the answer was wrong. So it's always best to go back to what you were given, unless you have to when you're calculating things. So for us, that means we're going to be dealing with our adjacent and now our hypotenuse. Looking at our SOHCAHTOA, that tells us we're going to be using the cosine ratio, which is, again, adjacent over hypotenuse. And we're just going to go through pretty much the same process. So our angle is 25 degrees. Our adjacent is now 18. And our hypotenuse, we don't know. So I'm just going to call it h. And we want to solve this. So remember, these ones are a little bit trickier. We're going to throw a 1 underneath the cosine 25. And we're going to cross multiply. So that means we've got h times cosine of 25. And we've got 1 times 18, which is just 18. And so if you remember from last week, we now want to isolate h, which means this cosine 25 has got to go. And so we're going to do that using division. So on the left, the multiplying by cosine 25 and the dividing by cosine 25 mean that these just cancel out, and we're left with just h. And on the right, we've got 18 divided by cosine 25. And so again, you're going to plug that into your calculator and see what you get. So I'll give you about 5-10 seconds, try that out, and see where you're at. All right, so you should, hopefully, have gotten 19.86 meters. So we've got two of our side lengths now. I've got 8.39 and 19.86 to go along with the side length we already knew, so those are good. We don't want to forget that angle as well, though. So let's get that last piece of information. Thankfully, that one's the easiest. So if you're looking at that angle, there's a few different approaches we could use. We could use trigonometry using two of the side lengths we know. But again, we don't know if those are absolutely correct, so we want to avoid it if we can. Instead, what we're going to do is go back to that thing I taught you about last week, in that all the angles in a triangle always add up to 180. So we know that this angle over here is 25. We know that this angle is 90, which means that if we put it all together, we can get our third angle pretty easily. So we just do 180 minus the two angles that we do know, which are 90 and 25. And that will get me my third angle. So 180 minus 90 minus 25 gets me 65 degrees. And when you're solving triangles and getting all these different pieces of information, it can be helpful to put it all together. So we've got 8.39 meters as one of our sides, which we'll just label with O for the opposite. We've got our hypotenuse is 19.86 meters. And then we had that angle, which if you look back up was angle B, is 65 degrees. We'll put a box around that. And there we are. We have solved a triangle. So, see how we do with the second one. And we're going to say this is 14 feet, and this is 26 feet, and we'll go from there. So what I'd like you to do is I want you to pause here real quick, and I want you to try to do this one on your own. So use everything you can, get all the missing pieces of information, any sides or angles you don't have, and then come back and see how you did. So if we're looking at our triangle here, there's currently three things that we don't know. We're missing this angle in the bottom left here, this other angle in the bottom right, and then this other side in the top left, which I'm just going to call x. So if we're going to solve this triangle, we need to find those three things. And we can do these in any order. I'm going to start with the side length just because we're only missing one of those, so that way we'll only have one, or have to deal with our angles at that point. So if we're looking at this, if we want to get that side length, we can't use trig because we don't know any angles. But what we can do is use the Pythagorean theorem. So remember that is c squared equals a squared plus b squared. And if we're looking at this, c, remember, has to be our hypotenuse, which in this case is the 26 because it's across from the right angle. So we're going to plug that in. C is 26 squared. A and b are interchangeable. I'm just going to say a is 14, which means b is going to be x. So if we're calculating this, 26 squared is 676. 14 squared is 196. And x squared, well, is just x squared. So if we want to solve this for x squared, remember we need to move that 196 over to the other side of the equation. So we're going to take both sides. We're going to subtract 196 on both. And we're going to get rid of those on the right. And so on the left, all we're going to have at this point is 480. Leaves me here. And so you'll remember, hopefully, that if we want to get rid of the square now, we're going to square root both sides. So that gets us x on the right. And if you square root 480, you should get 21.91. So that's how long x is, 21.91 feet. And if you look at the triangle, that seems pretty reasonable. Now we want the angles. So we can use trig for this, or rather we're going to have to use trig for this. And we can go in any order. So I'm going to start with this angle in the bottom left, which I'm just going to call theta. And so to get that, we're going to do trig, same as always. Looking from this angle, 26 is our hypotenuse, and 14 is our opposite. So if we put that all together, we're going to be using the sine ratio. So sine of our angle, which we don't know, is our opposite, which is 14, over our hypotenuse, which is 26. And so thinking back, if you want to get an angle with trig, remember you're going to use those inverse trig functions, which in our case is sine -1 of 14 over 26. And you're going to put that into your calculator. I'll give you a sec to try it out if you haven't already, and see what you get. So we should get our angle is 32.58 degrees, but remember, we're going to round this to a whole number, so we're just going to say 33 degrees. And our last angle here, we do have options. Again, we could do 180 minus 90 and then minus this angle, but if we messed up on the 33, that would get us an incorrect answer. So for now, we're just going to try to ignore the stuff we've already done and get the angle just directly. So that means we're going to be working from this other angle, which I'm going to call, I don't know, just call it y for now. So in that case, if we want to do from y, the hypotenuse is still the hypotenuse, but 14 is now the adjacent side, which means we're going to be dealing with cosine ratio instead of the sine ratio. So cosine of y equals our adjacent over our hypotenuse. And from here, it's pretty much just the exact same thing. We're going to use that inverse cosine, and we're going to get ourselves an answer. So we should get, hopefully, 57 degrees. And there we go. We've got everything that we were looking for. So we've got a side length, we've got a couple of angles, we've solved our triangle. So if we put it all together, we've got x is 21.91 feet. Theta was 33 degrees. And y was 57 degrees. And that should be everything we need. So one thing to think about, if we scroll down from this a bit, if I gave you a triangle where I just gave you the angles, if I said this was 30 degrees, this was 60 degrees, and that was 90, and I asked you to solve this, you wouldn't be able to. Because without at least one side length, you have no idea how big this triangle is. It could be very, very small, it could be very, very big, so there wouldn't be much we could do. So we have to have at least one side to know what we're dealing with. And that'll do it. So that is how you solve a triangle. You Just find everything that you don't already know.